What's up YouTube? Welcome to our 12th Python tutorial, and today we're going to be continuing our great venture into Python data types, and we are continuing today with learning the sets aspects of Python. So once again, we know that sets are another one of those 4 built-in data types in Python, and recently we've covered lists and tuples. So continuing with that, we're going into sets. So what exactly are sets? Sets are an unordered collection of items that do not allow duplicates within sets, and the elements of sets are immutable, but the set itself can be changed. And the special feature, the super duper special feature of sets, is that we can apply mathematical operations upon these sets. So you'll go ahead and see what we're going to be doing with all that down here. So let's go ahead and get started how we always do, and let's learn how exactly are we creating these sets in Python. And lucky for you, there are 2 ways that we're going to be learning how to make these sets. So let's get started, and I'll write the quick program, and once again, remember, whatever I write here, it will be down in the description below, along with the websites that I've used to get all this information and prepare this little video. So once again, let's get started with creating our sets. Alright, so here are our 2 ways that we're creating sets in Python. So the first way is the generic way that we always do, and that's through placing our values within our curly braces and then separating them with a comma. And here you see we have some nested sets within. So that's our simple way to define sets, and our little more unique way is through the use of the set function. So with the set function, you're simply typing in a string within, and it will convert our input into a simple set. And it's important to understand that no duplicates are allowed, so whatever string you input, it will break it down into only the unique values. So let's go ahead and run this program and see what it's doing. Right. So you can see our different sets being printed out. So we have our first prime number set, and then we have our number group set. And then here we are using our set functions once again, and it's breaking it down into its basic things. So it has D, A, R, B, C as the unique values, and within Alakazam, it's M, L, A, Z, C. So those are our 4 sets that we've created using the different ways. Okay, so now we're going to be moving on to covering the many operators and methods that are utilized by sets, and right now we're going to be doing difference, union, intersection, and symmetric difference, and you're going to see where all of this comes into play momentarily. So let's go ahead and get started, and I'll walk through and explain what each of them do once I've completed the different various ones. Okay, let's begin. Okay, so I've completed the 4 different operators/methods that we do when utilizing our sets. So first, it's important to compile this main thing. So what I've done is I've broken it down, and we're utilizing these 2 operators at the beginning for all of our 4 programs. So whenever testing our programs, it's important that we run this portion first. And you can see we've defined our 2 sets using our set function, abracadabra, alakazam, and we have our separated values and our unique values right here. So utilizing these sets, we're completing the different operator functions down below. Sorry, I can't speak at all today. But first, let's start out with set difference, and ultimately what set difference does, it's identifying the values that are only in A and not in B. And that, of course, depends on which one you keep first. So if I were to keep set B minus set A, it would pick the values only in set B. So it's whichever one is on the left-hand side of the operator. Okay, so let's print this out. So as you can see, both operators are doing the same thing, but ultimately what they're doing is whatever values that are only in set A and not in set B are being selected. So here you can see between these 2 values, A and A are similar, as well as C and C. So both A and C are being removed, and we're left with this smaller set, DRB in total. So for this next function, it is our union function, and basically it's utilizing set of elements that are either in A or B. So utilizing our operator right here, I'm blanking on the name of that operator, but it's the super tall line. So we have set A, super tall line, set B, and we're saying set union between A and B, and we're using our union function. So both of these once again do the same thing, and let's go ahead and test out our program. And you can see it's combining all of the values between our two sets, and once again it's unique. So earlier you saw that we had A and C similar, and ultimately in our final set it's just one big set with no duplicates. So for the third one, we have set intersection, and it's using the AND operator, and ultimately what set intersection does is it finds the values that are only in both A and B and discards everything else. So you can see with our function, once again, they're only A and C similar. So when we do this, we should be getting A, C or C, A, whichever way there. So once again, using our AND and our set.intersection, we are doing the same thing. And lastly, we're using symmetric difference, and symmetric difference is finding the set of elements that are in A and B but not both. So ultimately it's the reverse of this intersection, and here you can see once again it's discarding our A and C. So those are the four different operators / methods that we use when working with sets. So once again, that's our difference, union, intersection, and symmetric difference. So lastly, now that we've covered the four different methods / operations, it's of course time to get into our actions upon sets. So let's go ahead and get started with our actions, and I'll write out each of our programs and then we'll discuss them afterwards. Right, so these are the various actions that we cover with sets, and as you know, we mostly cover the addition of values into our sets and the subtraction and the removal of values in our sets. So let's go ahead and start out with the addition portion. So there are two methods that we utilize when adding values within, and that is our add method and our update method. So let me go ahead and define those quickly. Right. So once again, we have our add method and our update method, which both add to our overall set. And here you can see the add method only adds one value to the set, whereas the update method adds multiple values. And it's important to understand, once again, that when you're utilizing the update method and you add values that already exist within our set, what they will do is it will simply not discard them and not count them, and only add whichever is new. So when I go ahead and run this program, you'll see that we have 1, 3, 4, and here we have 1, 2, 3, 4 after adding our 2. And later, when using the update function, we already have 2, 3, and 4, and it will simply just add 5 and 6 to our overall set. And next, let's cover the removal portion of our modifying sets. So let me go ahead and define each of those methods. Right. So here we have our two removal methods, discard and remove. And what discard does is it simply, what discard does is it simply removes an element in the set if it exists, and if it doesn't, discard just chillaxes, stays back and doesn't do anything. Whereas remove, on the other hand, remove is the hothead. If it finds it in the thing, it will remove it, and if it doesn't, it's going to throw an error. It's going to start complaining. So let's go ahead and run this program, and you can see, once again, it's gonna have our initial num set, and then see we're removing 1 with our discard method, and then removing, when we're asking it to remove 2, which doesn't exist within our set, it simply doesn't remove anything and prints the same set again. And then with our remove function, once again, you see its removal abilities, removing 7, but when we ask it to remove 8, which doesn't exist within our set, it's going to throw a bit of a tantrum, right? So once again, these are our various applications of sets. I hope you guys understood mainly how exactly to create a set the two different ways, right? Using our brackets and using our set function, and then the different method operators that we're using. We have our difference, which ultimately is using the minus operator and the dot difference method, and it's finding the elements that are only in A and not in B. Then we have our union method, which is using this long tall operator, and it's finding the elements that are either in A or B, so it's a more inclusive one. And here with our intersection method, it is finding the one that are in both A and B. And our symmetric difference, which is a bit unique, it's finding the ones that are in A and B but not both. So once again, I hope this gave you just a quick overview of the different applications of sets. Sets are pretty interesting. This is one of my first times working with sets in a long time, and they always intrigue me. So I hope you guys had fun working with this and continue to practice all that we've covered so far. So by now, that is our lists and tuples, and we've added sets to that today. I know it's getting boring covering all these Python data types, so just hold on for one more. We have our dictionaries coming up, and then we get to work with strings, which are always more exciting, and I have a couple of challenge programs to go along with our strings. And once again, I'll be linking my material into the description of the video below. Have fun, and I think for those of you that are in middle school and high school, this is your finals week, so get to studying, and I will see you in our next tutorial.